in Module 3, we're going to start taking a look at quadratic equations. So in Section 1, we're just kind of introduce quadratics, review some things about them. So just to review, a quadratic is an equation where the highest exponent of the variable is squared. So it's usually written in the form y equals ax squared plus bx plus c, which is called standard form. So that's the typical form you have seen. The shape is a parabola, or you can refer to it as curve. So just kind of review a little bit about the shape of a parabola. So you can have a parabola that opens up, or you can have a parabola that opens down. A lot of the applications we discuss with quadratics typically follow a downward quadratic. There are a few that are upward, but most of them are downward. So one thing we're looking at is different things that can be modeled using a quadratic equation. So a quadratic equation actually models position of objects in the air. So like if you throw a ball, you release an arrow, missiles, throwing stones, all of those follow the shape of a quadratic. So it goes up into the air, slowing as it travels, then comes down again faster and faster. And that is modeled by a quadratic. We also have profit that can be modeled by a quadratic equation. So like if you create a new sports bike, computer, cell phone. So it actually takes into account two equations, your cost equation and your item, I guess you would call it, your sales, your expected sales. So you calculate those equations and then you do the costs minus the sales, and that is your profit. And whatever equations for your sales and cost get multiplied together to give you your profit. And then lastly, area of rectangular products can be modeled using a quadratic equation. So anytime you know the area of something like steel frames, fencing, construction uses a lot, and you know one length but you don't necessarily know the other length, you know area is length times width. If it's rectangular, you can use a quadratic to help you maximize the area or whatnot. So there are some key points of the parts of a quadratic that I wanted to review. So there's the vertex, which depending on which direction your quadratic opens is the highest or lowest point. You have your x-intercept or intercepts, because there can be 1 or 2 or 0, which are the points where the graph crosses the x-axis. More specifically, that's when your y value is 0. And then there is the y-intercept, which is the point where the graph crosses the y-axis. And in that case, the x value is 0. Now, a quadratic may not always have x-intercepts, but it will always have a y-intercept. Just kind of give you a graph with all of these labeled. So my parabola, this point at the bottom is called my vertex. Now, if my parabola opened down, the vertex would be the highest point. So it depends on what direction it opens. Then we have our x-intercepts, which I said there is typically 2, but there can be 1 or 0. And I actually realized I want to draw this a little bit differently so that there's a clear distinction between the vertex and the y-intercept, because kind of the way I drew it now, they're very similar to one another. So I'm actually going to draw this a little bit differently. I'm actually going to draw it opening down, and I'm going to move it over a little bit so it's easier to identify the vertex and the y-intercept. All right. There we go. Okay, so vertex, which in this case, because I changed to opening down, it's the highest point. X-intercepts, and then our y-intercept. So a couple things. If a quadratic opens down, it will always have at least one x-intercept. It could have 1 or 2, but it's going to have at least 1. If a quadratic opens up, it can have 0, 1, or 2 x-intercepts, because if it opens up, it does not necessarily have to cross the x-axis. One of your best friends when we're working with quadratics is going to be Desmos. So if you have not heard of it, it's an online graphing calculator that we're going to be using to help us graph quadratic equations. Just because graphing quadratics can get very difficult based off their equations depending on what they look like. So we're going to be utilizing Desmos a lot in this module to help us with quadratic equations. Let me know if you have any questions.